And happy Monday, everybody. Today we're going to talk about the mole. I know you might think, the mole, isn't the mole an animal? Well, the mole is an animal, but the mole is also a number. In chemistry, the mole is a number we use all the time. Okay. And the mole is equal to 6.02 times 10 to the 23rd power. This is really important. You need to memorize that. A mole is 6.02 times 10 to the 23rd power. So why do we use a mole? Well, a mole is a grouping number that's used to count really small things like atoms, molecules, or formula units. Apparently, atoms wasn't included there. Atoms are super small. And so a number like a dozen or a pair or a few is not going to be enough to do us any good. A mole is a counting unit similar to a dozen for eggs or donuts or a pair of shoes. So what does it look like when we write it out? A mole is 602 with a whole bunch of zeros in the back. After the 6, we have 23 place values there. So you can see, here are our hundreds, here are the thousands, the millions, the billions, the trillions, quadrillions, quintillions, and finally sextillions. So a mole is 602 sextillion. Now, can you imagine if every time you wanted to talk about a mole of atoms or molecules or formula units, you had to write or type all these digits in? And if every time you had to read about a mole of atoms or molecules or formula units, you had to sit there and count up all of your digits. How frustrating would that be? Very. So we go ahead and we use this quantity called a mole, and it makes life in chemistry much easier for us. Now, the thing with really big numbers is that we humans have a difficult time imagining the relative size of things that are really big. In our minds, in fact, we even have a difficult time conceiving of what a million is. So you can imagine, this is one of the reasons we get in trouble with things like national budgets, because in our brain, a million, a billion, and a trillion are really kind of the same, just giant number. But let's give some scale to this. If you had a mole of pennies and you wanted to divide it up equally with every single person on earth who is alive today, that's a mole of pennies. Every single person in the world would get $1 trillion. Okay, that's an enormous amount of money, probably more than you would be able to spend in your lifetime. All right. Now, if you take a look once again at the fact that atoms and molecules are really tiny, a mole of atoms is small enough to fit in your hand. And if you look at this picture here, you see that here is a quarter. For scale, you can see that this is a mole of copper, mole of aluminum, a mole of carbon. Okay, this is a unit of atoms that is something we can work with, something we can put on the balance and measure the mass of. So a mole is really useful for us. Let's get into a little bit more now. Okay, now we don't just use a mole by itself. We use it to go back and forth between quantities of atoms and the number of atoms or molecules or particles themselves. An analogy I might give you is we know that a dozen eggs equals 12 eggs because that's the definition of a dozen, right? 1 dozen times 12 eggs per dozen gives us 12 eggs, okay? We also have this equivalence. 1 mole of anything, in this case it's copper, equals 6.02 times 10 to the 23rd atoms of, in this case, copper. From this, we can make a conversion factor. If I have 1 mole of copper and I multiply that by our conversion factor, we get that we have 6.02 times 10 to the 23rd atoms of copper. All right, that's really by definition when you have 1 mole, but you hardly ever have 1 mole. So let's take a look at what it means to convert back and forth between particles and moles. All right, to begin with, let's look at the problem. How many atoms of gold are there in 2.6 moles of gold, AU? I want you to note here that the correct abbreviation for MOLE is MOL. I don't make this stuff up. This is really the truth. Yes, it only saves us the letter E. The reason why it's incredibly important to remember is it's easy to look at this and think that you're talking about molecules. That is not the case. MOL is the abbreviation for MOLE. Okay, back to our problem. Let's say we have 2.6 moles of gold, and we want to know how many atoms of gold we have. Well, that's pretty easy. We start with our known, and that's 2.6 moles of gold. And we multiply by our conversion factor, and a conversion factor, again, is a fraction made from an equivalence statement. Okay, when two things are equal, we can divide one by the other, and the answer is 1. And we get to use that as many times as we want to change what our initial value is. Okay, so in our known position, we have 2.6 moles of gold, and we are going to multiply it by this conversion factor, 6.02 times 10 to the 23rd atoms over 1 mole. Okay, that's because 1 mole is equal to 6.02 times 10 to the 23rd atoms. Therefore, this fraction is equal to 1. Okay, so we're going to do some canceling here. I notice that I can cancel moles, and I don't see anything else that I can cancel. My units remaining are going to be atoms and gold, which you can see here, atoms of gold. Okay, so now I put this into a calculator, 2.6 times, and I remember my scientific notation here, 6.02 second EE23, or if you're using a Google calculator or the calculator on your phone, it might have a little bit different keystrokes. You can always look that up. So 2.6 times 6.02 times 10 to the 23rd. Now we're working in two significant figures, so our answer will be 1.6 times 10 to the 24th atoms of gold. Okay, so let's try this one. How many moles of iron ore, how many moles of iron are there in 5.03 times 10 to the 25th atoms of gold? All right, let's work that out. In our known position, we're going to put the value that we know. We know that we have 5.03 times 10 to the 25th atoms of iron. Okay, and we know that our conversion factor is going to involve moles and a mole of some kind of particles. So in this case, our particles are atoms, specifically atoms of iron. I want to put those units on the bottom. I want to have atoms on the bottom so that I can end up with moles on the top. Well, I know that 1 mole is equal to 6.02 times 10 to the 23rd atoms. All right, so I'm going to plug this into my calculator. Oh, not yet. First, I'm going to deal with my units here. Let's change colors. All right, atoms are going to disappear. Atoms are no longer a part of my answer. Moles are going to appear now. I'm going to have moles of iron as my units. So I can go ahead and write that down. Moles of iron. Those are my units. All right, now I'm going to put into the calculator. 5.03 times 10 to the 25th power divided by 6.02 times 10 to the 23rd power. And what I end up getting is 83.6 moles of iron. And the reason I know it's this is I am working in 1, 2, 3 significant figures. So my answer should have 1, 2, 3 significant figures. Okay, well, I hope those examples will be helpful to you. I want you to watch the additional videos that I've put up for you, and I want you to do the practice problems. I will put up answers to the practice problems so you can check your work. But first, I'd like you to try it on your own. Thank you very much, and have a great day.